This is Dr. K. Raghuram Mohan Reddy, Associate Professor, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. The course name is Unconventional Machining Process. Okay. The topic is Definitions and Terminology of Electrical Based Processes. Okay, electrical energy based processes. Okay, right. So at the end of this session, student will be able to understand the definitions and terminology of electrical energy based systems or processes. Okay, so before we discuss the entire various process parameters and terminology, let us look at a glance. Okay, first let us start with electric discharge machining. Okay, right. General principles. Okay, definition: a machining process that uses electrical discharges to erode material from the workpiece. Okay, process description: electrical sparks are generated between an electrode and the workpiece, removing material through localized melting and vaporization. Okay, right. Electric discharge machining. Okay, so it will function with the combination of electrical and chemistry. Okay, so here electrical sparks are generated between an electrode and the workpiece, remove material through localized melting and vaporization. Okay, right. Next, power circuits for EDM. DC power supply. Usually in electric discharge machining we use or we operate with DC power supply, direct current. Okay. Here direct power supply provides direct current for generating electrical discharges. Okay, provides direct current for generating electrical discharges. Okay, right. Pulse generator controls the timing and frequency of electrical pulses. Okay, so here pulse generator is nothing but a regulator, okay, which controls the timing and frequency of electrical pulses. So usually these are very much important in terms of getting good surface finish and other qualitative aspects of the machine. Okay, so here pulse generator will play a predominant role in the surface finish, okay, or any other quality parameters of the machine. Okay, so which controls the timing and frequency of electrical pulses. Okay, right. Electrode and workpiece setup. Electrodes are shaped to match the desired cavity or feature on the workpiece. Okay, electrodes are shaped to match the desired cavity or feature on the workpiece. Okay, right. Electrode and workpiece setup. Electrodes are shaped to match the desired cavity or feature on the workpiece. Okay, right. Next, flushing. Purpose methods. Okay, purpose methods. Purpose: removes debris and maintains the gap between electrode and workpiece. Okay, removes debris and maintains the gap between electrode and workpiece. Okay, right. Methods: using dielectric fluids like oil or deionized water to flush the machining area. See, usually here the dielectric fluid not only for the required operation, okay, but also for the flushing the debris of the machining area. Okay, so here using dielectric fluids like oil or deionized water to flush the machining area. Okay, right. Next, mechanics of metal removal, spark erosion, material removal rate. Okay, right. Spark erosion. Electrical sparks cause localized melting and vaporization of the material. Okay, so electrical sparks cause localized melting and vaporization of the material. Okay, so here let us say, suppose if we want to machine at this area, okay, when we start working on this boundary of the profile, okay, in and around of this boundary of the feature, then definitely there will be some effect to the adjacent or bound above the boundary of the profile. But the thing is that with this, okay, suppose if we do conventionally, it will happen. But with this technique, with EDM, okay, the localized melting and vaporization occur. Okay, so in that particular, that is means that is nothing but surgical. Okay, surgical effect. Okay, right. Next, material removal rate (MRR) affected by the discharge energy, pulse duration, and electrode material. Okay, affected by the discharge energy, pulse duration, and electrode material. Okay, right. Next, process parameters: discharge current, pulse duration, electrode material. Okay, so first one, discharge current influences the intensity and rate of material removal. Okay, pulse duration. Duration of electrical pulses affects surface finish and machining accuracy. Okay, so duration of electrical pulses affects surface finish and machining accuracy. See, already in the previous slide that we have seen that pulse regulation. Okay, so here this pulse duration will be leading to surface finish and machining accuracy. Okay, right. Electrode material. Material used for the electrode such as graphite or copper affects the machining process. Okay, so material used for the electrode such as graphite or copper affects the machining process. Okay, right. Surface finish and accuracy. Okay, surface finish and accuracy. Quality of the machine surface often improved by adjusting process parameters. Okay, and machining accuracy. Precision of the machine features controlled by electrode design and process settings. Okay, right. Surface finish. Quality of the machine surface often improved by adjusting process parameters. Second one, machining accuracy. Precision of the machine features controlled by electrode design and process settings. Okay, right. Applications and limitations. Applications and limitations. Okay, applications suitable for complex shapes, hard materials, and precision components in aerospace and tool making. Okay, applications suitable for complex shapes, hard materials, and precision components in aerospace and tool making. Next, limitations. Limited to electrically conductive materials at slower machining rates compared to traditional methods. Okay, limited to electrically conductive materials at slower machining rates compared to traditional methods. Okay, but the accuracy will be good and precision will be ultimate. But only the thing is that only time. Okay, so the machining rate would be less. Okay, right. Key terminologies: dielectric fluid, spark, erosion. Okay, so non-conductive liquid used to cool the electrode at workpiece and flush away debris. Okay, non-conductive liquid used to cool the electrode at workpiece and flush away debris. Okay, next, spark erosion, removal of material through electrical discharges. Okay, so here removal of material through electrical discharges. Okay, so these are the key terminologies associated to this process. Okay, one is dielectric fluid, other one is spark erosion. Okay, so in dielectric fluid, non-conductive liquid used to cool the electrode at workpiece and flush away the debris. Okay, so that is the role of dielectric fluid medium. Next, spark erosion, removal of material through electrical discharges. Okay, so this spark erosion will remove the material through electrical discharges. Okay, so before we conclude, let me reiterate some important points. Okay, electric discharge machining. Okay, so general principles, definition, process description. Okay, a machining process that uses electrical discharges to erode material from the workpiece. Okay, a machining process that uses electrical discharges to erode the material from the workpiece. So that is the main principle of electric discharge machining. Okay, next, process description. Electrical sparks are generated between an electrode and the workpiece, removing material through localized melting and vaporization. So obviously the material removal will be in two phases. One is melting, the other phase is vaporization. Okay, so it starts with melting and gradually it will be vaporizing. Okay, right. So a localized melting means that it means there will not be any heat affected zone, and at the same time there will not be any damage to the adjacent of the outline of the way we are doing the machine. Okay, right. Next, power circuits for EDM. Okay, DC power supply, pulse generator, electrode and workpiece set. Okay, so in DC power supply, definitely we have to supply the direct current for generating electrical discharges. Okay, so without power supply we cannot generate electrical discharges. Okay, right. A pulse generator controls the timing and frequency of electrical pulses. Okay, so this pulse generator will play a predominant role to get the good surface finish and precision. Okay, right. Electrode and workpiece setup. Electrodes are shaped to match the desired cavity or feature on the workpiece. Okay, so here, whatever it may be the workpiece, the electrode profile would be very important in order to make the desired cavity. Okay, right. Flushing, right. Purpose, removes debris and maintains the gap between electrode and workpiece. Okay, methods, using dielectric fluids like oil or deionized water to flush the machining area. Okay, Right. Mechanics of metal removal. Spark erosion, material removal rate. Okay. Now let us discuss spark erosion. Electrical sparks cause localized melting and vaporization of the material. That's what we have discussed. Okay. So only that local melting and vaporization. Okay. That means there will not be any deviation from the boundary line of the profile. Okay. Suppose if you want to machine this area, okay, so there will not be any effect to the boundary of the boundary profile of the machining area. Okay, so here in this only the material removal should be taken and the effect should be limited to this area only. There should not be any heat affected zone or any stresses while we are machining at this boundary. Okay, right. Material removal rate affects are affected by the discharge energy, pulse duration, and electrode material. Okay, so material removal rate affected by the discharge energy, pulse duration, and electrode material. Okay, process parameters: discharge current, pulse duration, electrode material. Okay, discharge current influences the intensity and rate of material removal. Okay, influences the intensity and rate of material removal. Next, pulse duration. Duration of electrical pulses affects surface finish and machining accuracy. So already we have discussed that pulse generator, okay, controls the timing and the frequency of the pulses. Okay, so here pulse duration is that time pulse. Okay, duration of electrical pulses affects surface finish and machining area. Okay, next, electrode material. Material used for the electrode such as graphite or copper affects the machining process. Surface finish and accuracy. Surface finish, machining accuracy. Okay. Quality of the machine surface often improved by adjusting process parameters. Okay. Quality of the machine surface often improved by adjusting process parameters. Okay. Machining accuracy. Precision of the machine features controlled by electrode design and process settings. Okay. Precision of the machine features controlled by electrode design and process settings. Okay. Applications and limitations. Applications suitable for complex shapes, hard materials, and precision components in aerospace and tool making. Okay, so particularly when we use tools, okay, so tools only used for machining. So those tools must be very precision and accurate and hard enough to machine the workpieces. Okay, so in these applications we have to use these. Okay, and at the same time in aeroplane applications, okay, so in components of aeroplane must have high precision and why? Because it has to um, operate with high speed and the high altitudes. So there will be chance of great danger. Okay, when when we do not have the expected accuracy and precision. Okay, so whenever we go with components in aerospace, we must have high efficiency and high performance and high precision are very much required in manufacturing. Okay, right. Limitations limited to electrically conductive materials and here the machining rate is compared to other traditional methods is less. Okay, that is the only limitation. Okay, key terminologies associated to this process: dielectric fluid, okay, non-conductive liquid used to cool the electrode and workpiece and flush away debris; spark erosion, removal of material through electrical discharges. Okay, so with this, I'm concluding. Thank you very much.
Like, share, and subscribe. Hit the bell icon for more updates.